Hello everybody, welcome back to Maths. Hope everyone's doing okay. If this is your first session with me today, then please make sure you hit that subscribe button and like the video if you find it useful. In today's session, we're going to be looking into an introduction to probability. And we're going to be looking at some of the keywords, some of the key questions and that kind of stuff. So let's dive straight in. First question says an ordinary fair dice is thrown once. On the probability scale, mark with an X the probability that the dice lands on an even number. So let's think about what are the outcomes on a dice. So we've got 1, 2, 3, 4, 5, and 6. So an even number is going to be 2, 4, and 6. So that makes 3 outcomes out of a 6 total outcomes. I can simplify this to a half, and there would be half on the probability scale. So that's question A done. That's a nice easy 1 mark for us. The next question says write down the probability that the dice lands on a number less than 3. So let's identify which numbers are less than 3. Let's just erase these. So it does say less than 3, and I do get a certain number of students will always say, does that include the number 3? But just listen to what it says. The number has to be less than 3. So if it is the number 3, that's not less than 3, is it? So it has to be this 1 and this 2. So that makes that 2 possible outcomes out of the 6, which is 1/3. Looking at how the probability scale is actually separated. So I've got 1, 2, 3, 4, 5, 6 there. So these are all 6, aren't they? So if I want 2, 6, then 2, 6 must be this one. So it says write down the probability that it's, so if it was on the scale, it's that one, but I've not read the question properly. So yeah, it's just going to be 1/3. Okay, so yeah, hopefully that one makes sense. Let's move on to the next question. Okay, so let's look at what the words equally likely means. An event is considered to be equally likely if every option has the same chance of occurring. So for example, if I roll a 6 on a dice, my chance of getting a 6 is the same as getting a 1, getting a 2, getting a 3, getting a 4, getting a 5. If I flip a coin, my chance of a heads is the same as my chance of getting a tails. So because we know this, and we know that there's 6 on a dice and 2 on a coin, we can work out probabilities based on this. So for example, you roll a dice. What is the probability of a 6? Now, by the way, this is the correct notation. So P6, so P of 6, that's how we say that. So probability of 6 is what's the chance of a 6 on a dice. So chance of a 6 on a dice, well, there's 1 6 out of 6 possible chances. So that's our final answer. Next one is P of even number. So how many even numbers are there? 2, 4, 6. So that's 3 chances out of 6. Now, here's a key exam tip. You'll notice the question has not asked you to simplify it. So you don't need to simplify it because it says what's the probability. We've wrote down the probability, so 3, 6 is fine. If it says simplify, you must simplify to get the full marks. But in this case, 3 out of 6 is a probability. It says write down probability, so therefore we're right. But let's say, for example, you've gone to simplify and you've accidentally got the last bit wrong. That means even though the correct answer would have been full marks for this one, you've dropped yourself a mark by trying to simplify. So yeah, obviously get really good at simplification, but if the question doesn't tell you to do it, please don't do it because you will lose a mark if it's wrong. Next one is probability of a prime number. So let's just remind ourselves of what the prime numbers are. So prime numbers have 2 factors. Now 1 does not have 2 factors. We say 1 in itself, but itself is 1, so that's 1 factor. 2 is a prime number, 3 is a prime number, and 5 is a prime number. So you can see again, it's 3 out of 6. Now, square numbers. What are the square numbers? So from here, 1 is a square number, 2 isn't, 3 isn't, 4 is a square number, that's 2 squared. So 4 is, nothing else is, so that's going to be 2 out of 6. Okay. So yeah, hopefully that one is making sense to people. So let's move on to the next slide. Okay, so this one is the probability of not events happening. I probably said that wrong. The probability of events not happening, that's the way I should have said it. So the probability that Mr. Smythe, myself, wears a red tie is 5 out of 10. And the probability that he wears a black tie is 3 out of 10. Or no tie, obviously the other times. So what is the probability that his tie isn't black? So what I'll do is I can see the probability that the tie is black is 3/10, which means every other occasion must be not black. Does that make sense? If it's black, 3 out of 10 times, it means all the other occasions must be not black. So, or isn't black. So this one's going to be 7/10. Maybe let's write down the correct notation. So I'm going to put NB for not black, and that's going to be 7/10. Let's do question 2. Isn't red. So we can see that red, the chance of red is 5/10. So isn't red is the other 5 occasions, isn't it? So that one, P of not red, is equal to 5/10. And again, remember, we don't need to simplify unless it tells you to. Next one is neither. So it's neither black nor red. So if it's not black, it's black 3 times and it's red 5 times. So it's either red or black on 8 occasions, isn't it? Because we can add those probabilities together, which means the other 2 occasions, it is neither of them. So we can say probability of, maybe let's just write down the word neither here, and that's going to be 2/10. Again, we don't need to simplify. And this one is red or black. Well, if it's neither 2 out of 10 times, it must be both of them on, let's put both. No, it's either, isn't it? Let's put either. Let's put that in there. Okay, and that's just going to be 8 out of 10 times. Okay, hopefully that one is all okay. Let's have a look at the difference between an independent event and a dependent event, because I've seen plenty of exam style questions, and I'm going to show you some similar sort of things in a moment on the next slide, that ask you why is this independent and why is this dependent. So you might want to take notes and jot this down. An independent event is an event which is not affected by the previous event. So for example, I was going to get a coin, I haven't got one, but flip a coin and you might get a heads. Does that mean that your chance of getting a heads on the next throw is more likely or less likely because you've just got one? So I flip a coin and I get a heads. My next throw, I've still got a 1 in 2 chance of getting a heads. I flip a coin again, I've still got a 1 in 2 chance. I could flip a coin 1,000 times. Every single individual chance is always 1 out of 2 for heads, no matter what's happened before or what's happened afterwards. And every single event, it's always 1 out of 2. That's an independent event. Now, a dependent event is where the previous event has changed what's happening to the next event. So let's give an example. So let's say I've got a bag, and let's say I've got, let's put some, I'm not doing that exact example there, but let's do this. So yeah, I've got a bag and I've got 3 red blocks or circles or balls, whatever you want to call them. I'll call them blocks actually. I've got 3 red counters, blocks, let's call them blocks. 3 red blocks and 2 red, I'm going to start this again because I'm going to say balls. I've got 3 red balls and 2 blue balls. Okay. I don't know why I'm struggling to say that. I've got 3 red and 2 blue. I'm going to say that. I don't know how I couldn't get that out. Anyway, so if in event 1, I pull one out at random and I say, well, what's the chance of me getting a red? So let's do P of red, chance of getting a red. Well, my chance of getting a red is 3 chances out of 5 total blocks. But I've taken a red out and now I'm not going to put it back in the bag. Okay, so it's not being put in the bag. So that's now gone. So then we say, what's the probability of you pulling out another red? Well, I've only got 2 reds now, and it's out of 4 choices, out of 4 chances, which means the probability, look, has changed. So if the probability from one event to the next event has changed, that would be called dependent. So let's have a look at a couple of examples. We won't go over them all, but if you want to do these yourself, you can do. So we're going to say, are these independent or dependent? So if I roll a 6 on a dice, that's event 1. So I've just gone, right, I've got a 6. I'm going to roll another 6. Has that second 6 been affected by the first 6? No, it hasn't, which makes it independent. Next one, there's a javelin thrower and they throw it 60 meters. Then their second throw, they get 58 meters. Do you think their second throw has been affected by the first throw? So you can pause the video at different stages and see if you want to answer these yourselves. But yeah, this would be dependent because maybe your arm's tired, or maybe 60 meters was a personal best and you're trying to throw it further and you've messed it up or something, or maybe you're not happy with 60 meters and you're frustrated, whatever, it's going to be affected, isn't it? It's very, very unlikely that it's going to be independent. Next one is I flip a coin and get heads, and I flip a coin and I get another heads. A coin is going to be independent, so that would be I for this one. I walk across a road, that's event 1, and then a car slows down. Maybe that's a key word there, me saying and then. So I walk across the road and then the car slows down. That would be dependent because the car slowing down has depended on me walking out in front of the road. Next one is it's raining and having maths on period 5. I kind of put these in as a bit of a jokey one because I used to teach some class on period 5, and it doesn't matter how much it's raining outside, you are going to be having maths period 5. So those two events happen independent to each other, unless of course it's torrential rain and maybe there's a flood and we have to cancel period 5 anyway. Next one, there's 5 counts in a bag, 3 are red, 2 are blue. That was the example we did in the previous page, which was dependent, wasn't it? So let's just go over that one more time. So we've got 3 counters in a bag, so 3 red counters and 2 blue counters, and I take out a red. There's now only 2 left in the bag. So the probability has changed, hasn't it? So that's why it would be dependent. Next one is event 1 is you are hungry. Event 2 is you are eating now. You are probably eating because you are hungry, therefore it's depending. Okay, it is snowing heavily and you're at school. Well, you're probably at school. That would probably be affected by it snowing heavily because we have snow days, things like that. So I would say it's probably dependent. Although with these maths questions and the exam questions, you can, as long as you can argue your point really well and you can back it up, because this is a kind of question where you could probably argue either of them, couldn't you? And as long as you can argue your point and you can put it across well, then that would be okay, and you'd probably still get the full marks for it. Okay, but here's a quick tip. Try not to be too clever with your answers. I want you to think about not what maybe you think, but what would the examiner expect you to write? So for that one, snowing heavily, you're at school, I would imagine they want you to write down that it's dependent because if it snows too heavily, that affects the possibility of you being at school, therefore you might not be at school. But if you try and be too clever and go, well, actually, well, it has to be this sort of snow and it's not snowed too much, so we're not going in, so we're fine, whatever, you might trip yourself up. So try not to be too clever. Try and think about what do they want you to answer. Okay, let's now have a little chat about mutually exclusive events. So these are 2 events that cannot happen at the same time. So get a coin, flip it. Can you get a heads and a tails? Now some people are like, well, you could get on the side. Well, that's neither, isn't it? So if you flip a coin, you cannot get heads and you cannot get tails in the same throw. So those 2 events are mutually exclusive because they cannot happen at the same time. So let's have a look at a few examples. So we've got our roll of dice, like we said there. If I roll a dice, can I get even and odd? Well, I can't because all numbers are either even or odd. Can I get an odd and a prime? Well, 3's a prime. Let's jot this one down actually, because that's a good example. So I roll a dice. Is it possible that I can get an odd and a prime? Well, we've got 1, 2, 3, 4, 5, 6 on a dice, haven't we? So that's an odd prime and that's an odd prime. So you have to give the example to say this is why it's not mutually exclusive. So that's why it's not mutually exclusive. Even and prime, well, that's a 2. And as long as you give an example, you can prove either way. Okay, so that is the video there and there. Hope you found that useful. And like I said, if you haven't subscribed, make sure you hit that subscribe button and I shall see you guys in the next one.